Most people's view of the world is limited to a small patch of Earth where they live. Traveling and watching educational programs expand those narrow boundaries a bit. But what lies beyond our planet, deep in the cosmos, remains largely a mystery to humanity. For example, do you know what hides at the center of our galaxy? Is it absolute emptiness, a parallel reality, or a gateway to another universe? Modern science has pondered this question too, and some fascinating discoveries have been made. The journey to uncover these secrets takes us through layers of dust, gas, and gravitational forces that have puzzled astronomers for decades, revealing a dynamic heart that beats with the energy of creation and destruction. It's a place where the laws of physics are pushed to their limits, and the scale of everything challenges our everyday understanding of the universe. Many folks think monsters only exist in fairy tales and horror movies, but that's not true. One of them is lurking by cosmic standards, right next door at the center of the Milky Way. We're talking about a supermassive black hole that packs in 4.3 million times the mass of our Sun, with a diameter of 44 million kilometers. Its name is Sagittarius A*, and it's a colossal force shaping the heart of our galaxy, pulling in matter with an unyielding grip that warps the very fabric of space-time. Imagine something so dense that not even light can escape its pull, a silent guardian or predator at the core of everything we see in the night sky. This black hole isn't just a void. It's an active player in the galactic drama, influencing the paths of stars and the flow of cosmic material across vast distances. But what else can you find in this extremely hostile, dark, and eerie place? There are massive star clusters, along with huge amounts of dust and gas, all swirling in a chaotic dance influenced by this central giant. These clusters are packed with young, hot stars that light up the region, creating a stark contrast against the darkness, while the dust and gas form dense clouds that obscure our view from Earth. The center of the Milky Way is anything but calm. The monstrous gravity of the black hole, which is thought to house a powerful radio source at its core, stirs up constant stellar storms and waves of disturbed matter. When these collide, they heat up intensely and shine brilliantly, creating bursts of radiation that light up the surrounding space like fireworks in the void. These events are not random. They're the result of gravitational interactions that can fling stars at incredible speeds or tear apart gas clouds, releasing energy equivalent to millions of nuclear bombs. It's a turbulent zone where new stars are born from the compressed gas, even as others are doomed to be pulled toward the black hole's event horizon. Let's get back to the star of our story, the black hole. What does discovering such a powerful and dangerous object mean for us? Could its activity threaten Earth's habitability in the future? Might this cosmic beast endanger the very existence of our planet? These questions have kept scientists up at night, analyzing data from telescopes around the world and in space, piecing together models that simulate the behavior of this distant giant. To start, let's figure out how often these titanic conglomerates form at the hearts of galaxies. Years of research by astronomers suggest this isn't rare at all. Almost every galaxy has a similar monster at its core, acting as a gravitational anchor that influences the motion of billions of stars and helps shape the overall structure of the galaxy. Observations from telescopes like Hubble and the Very Large Array have shown that these supermassive black holes are common, from spiral galaxies like ours to elliptical ones across the universe. But how did it get there? The most popular hypothesis goes like this. Imagine a large cloud of gas forms a relativistic star, which quickly loses equilibrium and explodes. But this explosion isn't like the death of a supernova or hypernova, where massive amounts of material are ejected outward. Instead, the hypernova star collapses instantly, skipping the stage where it ejects significant amounts of matter. It's this moment that allows the object to retain its enormous weight, necessary to transform into a heavyweight black hole. Think of it as a star imploding under its own weight, compressing so tightly that it punches a hole in reality itself, becoming a point of no return for anything nearby. This process could happen in the dense, early universe when gas clouds were abundant, leading to the formation of seeds that grew over time by accreting more material. Some scientists disagree with this idea and believe that primordial black holes originated in the young universe due to massive disturbances from the Big Bang. These spatial funnels then grew to enormous sizes, building mass through the accretion of matter, slowly accumulating gas, dust, and even entire stars over billions of years. This theory suggests that black holes were among the first structures to form after the universe's birth, serving as building blocks for galaxies rather than the other way around. The center of our galaxy has intrigued scientists for a long time, but it wasn't linked to any specific astronomical object until 1960, when astrophysicists noticed a strange radio source in the constellation Sagittarius. Before that, a dense veil of cosmic dust blocked the view, obscuring the intense activity happening there and making optical observations impossible. Once infrared astronomy kicked off, where dust clouds aren't an obstacle, active scanning began of this mysterious region, nearly 28,000 light-years away from us. Infrared light penetrates the dust, allowing us to peer into the galactic core like never before, revealing a bustling hub of stellar birth and death that was hidden for centuries. The black hole at the center of the Milky Way was discovered by observing the anomalously shifted movements of stars, which orbited at incredible speeds, sometimes approaching a fraction of the speed of light. These stars move in elliptical paths that betray the presence of an invisible mass tugging at them, providing the first concrete evidence of Sagittarius, a asterisk-s existence. Now, back to the question of how dangerous this lurking monster is for us. According to astronomers' observations, a black hole settled in any galaxy is like a time bomb, quietly ticking away until conditions change. At some point, its activity could spike dramatically, leading to unpredictable consequences that ripple across vast distances, potentially affecting star systems light years away. At the same time, Sagittarius A* is an integral part of the Milky Way, which formed and evolved alongside it, shaping the galaxy's structure from the inside out over billions of years. Scientists think that by absorbing matter and ejecting energy, it triggers the birth of new stars and supplies our galaxy with material. This also helps form new planets, recycling cosmic debris into fresh building blocks for solar systems like ours. The black hole acts as a cosmic engine, compressing gas clouds to ignite nuclear fusion in new stars and dispersing heavy elements forged in stellar furnaces. If there were no black hole, the Milky Way would resemble billions of shriveled dwarf galaxies, looking like someone forgot to turn on the lights in the dark depths of space, devoid of the vibrant star formation that makes our night sky so alive. Without this central force, the galaxy might lack the density needed for complex structures, resulting in a sparse, dim collection of stars drifting aimlessly. So, it turns out the monster isn't that scary after all. In fact, it's even useful because thanks to the black hole, the Milky Way continues to evolve, giving birth to millions of new stars and planets. That's one side of the coin, but there's another. Considering the possibility of rapid and significant activation of this enormous cosmic object, Along with a host of unforeseen circumstances, the danger still looms over the Milky Way as a whole and Earth in particular. For example, if a surge of gas from a passing cloud or a stellar collision feeds the black hole, it could flare up, emitting powerful jets of radiation that sweep through the galaxy. Of course, a mass of 4.3 million solar masses isn't that much for a black hole. Scientists know of much larger beasts. For example, in the constellation Coma Berenices, there's a black hole weighing 21 billion solar masses, a true colossus that dominates its host galaxy. And the largest known one hides in the constellation Canes Venatici, with a mass of 66 billion solar masses, making Sagittarius A* look like a lightweight in comparison. These giants dwarf our own. Yet even Sagittarius A* has the potential to disrupt if conditions align, perhaps during a period of increased accretion or interaction with nearby stars. Scientists believe that the average size of our home monster allowed for the creation of all the preconditions for the formation of the solar system and, ultimately, the emergence of life on Earth. If the black hole were much larger and more active, it might have consumed too much material early on, starving the outer arms of the galaxy where our sun resides. Or if smaller and more passive, it could have failed to provide the gravitational stir needed for star clusters to form. But the medium size of the object maintains a safe balance, providing just enough gravitational influence to keep things stable without overwhelming the system, allowing for the delicate conditions that led to habitable planets like ours. However, despite its relatively modest size, the resident of our Milky Way's central region could cause plenty of trouble under certain circumstances. What consequences await humanity if that fragile balance is ever disrupted? Let's explore some possible scenarios that astronomers have modeled based on observations and simulations, drawing from data collected over years of study. One scenario is the transformation of the Milky Way into a quasar. Let's clarify right away that quasars typically form in young galaxies at the beginning of their evolution. But that's just an assumption that could be wrong, as new data suggests older galaxies can flare up too. What is a quasar? Essentially, it's an overfed black hole that has gobbled up so much stellar material that it starts actively emitting radiation and light. This would be visible even from billions of light years away, shining like a beacon across the universe, outshining the combined light of all the stars in the galaxy. In normal conditions, there's not enough material around the black hole for this dangerous transformation. A random star snack doesn't count. But if food for the monster becomes abundant, perhaps from a galactic merger or a massive gas influx triggered by some cosmic event, the galaxy is in trouble. First, the Milky Way's life would shorten to a mere few million years, a blink in cosmic terms compared to its current age of over 13 billion years. Second, the huge funnel, like an insatiable mouth resembling a sewer drain, would grow larger, mercilessly pulling in all objects in its path, including star systems and clouds that could otherwise form new life-bearing worlds. The process of devouring matter wouldn't stop until nothing was left of the galaxy. After that, the quasar would fade out, curtains leaving behind a barren void stripped of its former glory. A hellish collision is another possibility. As we know, our nearest neighbor, the large spiral galaxy with the romantic name Andromeda, will inevitably collide with the Milky Way in about 4 billion years. This event, part of the universe's ongoing dance of gravity, could also disrupt the stability of the central black hole. Naturally, the cores of both galaxies would suffer a serious shock, with stars being flung about like confetti in a storm, some ejected into intergalactic space, while others are captured in new orbits. But that's only half the trouble. The horror is that Andromeda's center also houses a black hole, much larger than ours, estimated at 100 million solar masses, and it's not alone. By the number of such objects, our neighboring galaxy is a true champion, harboring multiple supermassive black holes that could interact in chaotic ways during the merger. During the collision, they would start interacting, tangling planetary orbits, knocking stars off course, hurling some objects into space, and simply tearing others to shreds. Amid all this Armageddon, the black holes could seriously activate, as in the previous scenario, turning into a deadly quasar that erases the populations of both galaxies from the face of the universe, leaving a merged remnant scar by the encounter and potentially uninhabitable for eons. Simulations show that such mergers can trigger waves of star formation, but also violent outbursts that sterilize vast regions with radiation. Wandering sisters are yet another concern. Scientists fear that the black hole at the center of the Milky Way isn't alone. There may be several relatives scattered across our galaxy, and that's far from reassuring. For example, last year, scientists from Keio University in Yokohama obtained irrefutable proof of another black hole's existence, about 200 light-years from the Milky Way center. Using a telescope in the Atacama Desert, astrophysicists determined that the object has a diameter of 1.4 trillion kilometers. This means the new one is much larger than Sagittarius, a asterisk, raising questions about how it formed and what role it plays. Computer models suggest it's the largest object discovered in our galaxy so far. It's unclear how two such beasts will coexist in such dangerous proximity and what consequences await humanity if they emerge, potentially unleashing waves of gravitational energy that could ripple through the stars, disrupting planetary systems and altering the galaxy's structure in unpredictable ways. In short, the black hole is sleeping for now, but no one knows what might ignite the cosmic fuse, setting off a chain of processes that could destroy our galaxy. The only consolation is that the described scenarios, if they happen, won't occur anytime soon, so neither we nor our nearest descendants will likely witness this nightmare. The black hole is a dangerous neighbor that could wipe us out from afar, and its main weapon is a gamma strike. These rays appear when a massive funnel activates. They're invisible, move at the speed of light, and destroy everything in their path, including human DNA bonds. If such a burst from our galaxy's center heads toward Earth, it means instant death for people. But given the low probability of such a threat, it's like how irresponsibly we treat our own planet. Humanity should be more worried about not frying ourselves through climate change or other self-inflicted disasters, as our actions could render Earth uninhabitable long before any cosmic catastrophe arrives. If this exploration into the heart of our galaxy has ignited your curiosity about the universe's hidden forces, subscribe to join us on more adventures through the stars.